Hi, I'm Paul. We're doing Leetcode must know interview questions, and today's challenge is, whoops, let me get to the top here, implement trie, prefix tree. This is rated as medium. I think it would be kind of hard actually to implement this, if somebody sprung it on you at a coding interview and you hadn't seen it before. Now you will have seen it before. So a trie, or sometimes called a prefix tree, is a tree data structure used to efficiently store and retrieve keys in a data set of strings. Various applications include autocomplete and spell checker, implementing the trie class. I'll show you like a simple example of a trie, but I wish they had a visual example here. To implement the trie class, we have a constructor to initialize the trie object. We have an insert method that takes a word as input and inserts the string into the trie. We have a Boolean search method. It takes a word and returns true if the word is in the trie, and false otherwise. And then we have Boolean starts with. It takes a prefix and returns true if there is a previously inserted string that has the prefix, the input to the method, if that exists as a prefix. All right, let me scoot this over and show you like visually what a trie looks like. Let's get a pen. Okay. So a trie is a tree structure. It has let's say a root, and let's say we want to add the word and. Okay, so we look at this. Does the letter A exist already in the tree? And it doesn't. So let's go ahead and add it. So we've got an A. Is there an N under the A? No. All right, so let's add that. Is there a D under the N? No. So let's add that. I'm gonna put and here because trie nodes have an end of word indicator. So the word and is different than just the string of three letters A and D. Let's add another word. Let's add ant. Ant as in, the insect. So we would say, is there an A under R? And there is. Is there an N? Yes. Is there a T? No. So let's add that. And again, it's going to be an end of word indicator. Now we have two words in the trie. Let's add the word dad. Is there a D under the root? No. We're going to add one. Is there an A under the D? No. Can I draw here? It's going to make me undo that. All right. D. Is there an A? No. We'll add it. And is there a D? No. But we have a new word. Okay, we'll add one more word. D-O, do. Is there a D under the root? Yes. Is there an O? No. So we can add that as another word here. All right, so that's what a trie looks like. We'll go into the implementation. But actually, let's look at example one, where we have a series of calls to a trie data structure. So what would happen here under explanation? All right, so we could say trie equals new trie. We can insert apple. We can search for apple. That should return true. We can search for app. That should return false. Even though the string of letters APP does exist in there, as I said, the trie node will have an end of word indicator. And we didn't insert the word app. So app is not going to be recognized as a word. It'll return false. We'll do trie starts with. That returns true. APP, yes, it's in there, but it's the prefix of another word. Then insert the word app, which would put an end of word indicator at the end of app, and then do another search for app, and that'll return true. Okay. So let's try an implementation. Move this over. Okay. We're going to need another class here for the nodes, trie nodes. So let's say, class trie. I guess it could be a private class, private class trie node. What is going to be in here? We're going to have an array of children. Really, these are letters, except that they also have, as I said, an end of word indicator. So each trie node has a 26 element array, which could be any of the, you know what, I didn't really go down on the constraints here, but there is a constraint that says we're only going to have lowercase letters. Okay. So is end of word. Yeah, each trie node will have a 26 element array corresponding to letters A to Z. All right. Let's get a constructor here. Public trie node. All right. The children will consist of a 26 element array, and is end of word will initially be false. All right. Now we need a constructor for the trie, and actually we need a class variable here for the root. Private trie node root. Okay, in the constructor, really all we need to do in the constructor, what are we doing here, by the way? Oh yeah, insert starts, okay. All we need to do for the constructor is to say that the root equals a new trie node. So we've got a starting place. All right, now insert. Trie node, not tire, trie node current equals root. All right, so as we insert a word into the trie, current is gonna change. It's gonna be the most recent letter that we put in. Our starting point is going to be root, and then we'll say for int I equals 0, I is less than word dot length I plus plus. Okay. We need a character, one character at a time. Character C equals word dot char at I. All right. Does it exist already under the root? If current children. And we are going to convert letters to numbers. We're going to convert the lowercase letters A through Z to indexes from 0 to 25 by subtracting the lowercase a character, all right? So if that does not exist already, then we're going to add a new trie node for it. Okay, so now it does exist, and we are going to set current to the last node that we processed. And we'll go through and process the whole word that way, adding letters as needed. And because it is a word, once we get to the end, we'll set is end of word to true. All right. So that's the insert. Okay. The search. All right. Again, search. Search is going to start from the root. Trie node current equals root. The loop, I don't know, the loop is, some of it's going to be the same. I could save some typing here probably. All right, so we are going to go over each letter in this word that we're searching for. However, if we find a letter that doesn't exist, obviously we don't add it, we just return false. That word doesn't exist. And if it does exist, then we go to the next letter. What do we return? What we return is, well, if we get all the way through, we're going to return current is not equal to null, and it's the end of the word. So let's see, we go through here, we get to the last one. Current equals A. I guess if we get there, really current should not equal null because it would have returned false. I'm going to leave it there. I don't know, just kind of a safety net. I think it'll probably work if we just return current is end of word, but okay. Oh, and then starts with. Well, starts with is actually going to be the same as search, except that we just don't care whether it's the end of a word. So starts with, we start at the root, iterate through the letters. If we don't find a letter, we return false. If we get all the way through, then we don't care if there's an end of word indicator. If we get all the way through, we're just going to return true. I'm going to try this. And if it doesn't work, I'll put it back in. But I'm not sure we need that. Okay. And let's try running it. Compile error. What's the compile error? Oh my God, are you kidding me? I forgot all those semicolons. 21, 34, 47. Well, that's what I get for copying and pasting. Okay, got one there. Got one there. You've got one there. Try it again. Compile error. Private class. Modifier is not allowed here. Why not? Oh, and a misspelling on line 7. All right. So I can't do a private class in here. And then line 7 is end of word. All right, run it. Can't find the symbol. Oh, I misspelled that too. Unbelievable. Is end of word. Okay, yeah. All right, another copy and paste error. String word, and this is actually string prefix. So we got to do prefix here. Okay. Try it again. File error. It's in 2 places. Yes. All right. Wow. This is a new record for compile errors, I think. That was accepted. And then let's try and submit the whole thing. That worked. 35 milliseconds. 35 milliseconds. It's still ahead of the curve. All right. So that's it. That's how you implement a trie. The main things that you do with tries. Again, you can use them for different kinds of implementations, but these are the main things that you do. Is you insert strings, you search for strings, and you search for the prefix. So search for the prefix of strings. So I hope you enjoyed that. Sorry about all the compile errors. What else? Please feel free to like, subscribe, comment, and see you next time.